All right, the last section today is 4.6. What roles do species play in an ecosystem? And we'll actually talk about that next. Hey scholars, welcome to 4.6. In chapter 4.6, we're looking at what roles do species play in ecosystems. And so we're going to look at how those species really impact their ecosystem that they live in. One of those things that we talked about within our case study earlier today, or well, I guess yesterday, since you're watching this the day later, is that each species does play a unique role, and that is called a niche, not a niche or a niche. It is a niche, okay, ecological niche, and it's basically how that organism helps the ecosystem. What role does it play in the ecosystem that would actually help the ecosystem as a whole, not just themselves. There are two different types. Usually, there's generalist species, which have a very, very broad niche, which that means they kind of cover a lot of ground. They do lots of different things for the ecosystem. And there's organisms that are called specialist species that have a very narrow niche, very small. They only serve specific roles in that environment. So they don't really, they're not like that. That's not like that each of them don't benefit other organisms, just that they each play a different role. One of them is very narrow, and they only have specific roles. The other one is kind of very broad and covers a lot of different ground. So those are two different types. Some examples are these guys. The panda. Very, very narrow niche, very specific. It obviously eats only bamboo. It only lives in one type of habitat. It's very, very specific for what it does. Whereas the generalist species, the raccoon, can live in many different habitats. Number one, eats a variety of different things, all sorts of stuff. It's omnivorous. It eats plants. It eats meat. It eats a whole bunch of stuff. It can live in cities. It can live in your attic. I mean, it can live in a whole bunch of places. It's very, very broad as far as where it lives and what it does. So those are the difference between a specialist species and a generalist species. So one of the case studies, a very, very generalist species, the cockroach, which I'm sure if you look around, maybe you'll see some, hopefully not in your house, but you will definitely see them at White Oak, I guarantee you that. They are nature's ultimate survivors. Maybe you've seen the movie WALL-E, where his little sidekick is a cockroach. I mean, he runs over it, he zaps it with things, it still lives no matter what. It's living on a planet which doesn't even have any plants or any other life available, so it's kind of unique. But cockroaches are very generalist. They live in many different habitats, in your home, in the garage, outside, all sorts of places. And they have very high reproductive rates. Lots of babies. They don't really parent very well, but they have lots of children. The giant panda and a tiger salmon are very specialist species. They have very low reproductive rates. They don't reproduce. Some of them only reproduce every 2 years, like the giant pandas. So very, very tough for them to survive. The more generalist you are, usually the better off you are at survival. So that's just what we take away from this case study. And we're going to skip past this picture pretty quick because I'm sure you've all seen them. Pretty gross. One of the things is that specialists also they have feeding niches. So in order for organisms to thrive, many different organisms to thrive in one habitat, you don't want any what we call niche overlap, where you're feeding on the same things, doing the same role. So a lot of times, in this case with birds, you can still specialize by what you feed in order to thrive and serve a purpose in their habitat. So for instance, going over here to the black skimmer, it obviously eats fish and things off the top of the water, out a little bit more in the water column, kind of deeper ocean that way. Whereas the flamingo feeds on very, very small organisms found in the mud. It has a long neck to get its head down there and feed off those. Mallards eating different mollusks, crustaceans, aquatic vegetation. Brown pelicans diving in for larger fish. The heron, can wade in very shallow water, not really violent water like the ocean waves, but in more calm conditions. You have oyster catchers that are feeding on shellfish, mussels specifically. Lots of different. Based on their beaks are different for what they eat, and they are very, very specialized for what role they play, even in that small little section of a beach area. So niches can be occupied by native and non-native species, which is kind of the whole purpose. Well, the purpose of the discussion of non-native species. Most time we have native species who thrive in a specific habitat. They've been doing it for thousands of years, and they really played their role well. Well, sometimes the new guy comes in and plays the role even better. So kind of like, I don't know, if you're on a football team, right? Running back, we're using football since the NFL, and I love fantasy football. So let's put it this way. We have a football player who's a running back coming in, running really well, puts up 1,000 yards, but, he might get injured for a couple weeks. Well, this other guy, his backup, comes in, steps in, and runs for, back-to-back games, 350 yards apiece, which is crazy numbers. They might leave him in for longer, and if he takes over, then he's out-competed him for his job. Same thing works with non-native species. that have not been here before, but maybe they just better suit that environment better than the native species, and they can come in and spread rapidly and outcompete the native species. That's when we call them invasive or alien species. Okay, when they really come in and they do some damage, they spread rapidly, and they outcompete native species. That's when they become bad. If they're not native species that comes in and just kind of thrives regularly, without really outcompeting anything and really not taking over any resources, they might not have to be really villains, for instance. Okay, they don't really have to do any major bad jobs of really, and they're not really looked at as negative contributors to the environment. So that's just a couple of most non-native species though become invasive. That's how they get good at outcompeting, and which always leads to bad things. So that's just one example there for you. All right, indicator species. This is another different type of species. These ones are looked at, those are basically biological alarms. They're like saying, hey, something's wrong with the environment because whether it's water quality or air quality, they're saying, hey, something's wrong. If my numbers of my population are going down, or you're seeing injuries to my members of my species, there's a huge issue with the environment. You gotta look at something. So they're very good at monitoring, like trout, for instance. They live in very cold streams. They're very sensitive to pH and different things in the water. So if their numbers start to go, that could be a cue that your water quality is going down. Same thing with birds and butterflies. They live in the air. They thrive in the air. If something bad is happening, oxygen or air quality-wise, they're going to let you know. And frogs the same way. They're aquatic. They live in marshes. You know, marshes are great filters for pollutants, but if they get over polluted, then that can lead off and show in the species of frogs with either death or I've found frogs with 5 legs before. Remind me to tell you that story in class tomorrow about the 5-legged frog that I found and why I found it. So ask me that tomorrow. Case study, why are amphibians vanishing? Well, a lot of times, you know, we talked about this before, people in Brookstone who live out that way, you know, have habitat loss because of the fact that they filled in those wetlands to build houses. And a lot of times that happens. And amphibians, they need water. They need water and land. That's what amphibious means. So if they lose their habitat, then they're not gonna have anywhere else to go. They have to have that specific type of range. So that's one way. Prolonged drought. You know, if we have long periods of drought, that can kill them as well. Pollution. You know, water. They're very susceptible to water pollution. That's why they're a good indicator species. If they have increased UV radiation, you know, that is a bad thing as well. Different parasites. When their skin is in more of an acidic environment, they can be more susceptible to parasites and viral and fungal diseases. And that can also happen if their temperature goes up from climate change, they're also more susceptible to viral diseases and parasites. And even overhunting, you know, for frog legs, not really, but legitimately, if they are overhunted or overtaken, that can be a problem too. And also, probably another big one, non-native predators coming in and competitors that come in and outcompete or kill the amphibian as a prey item. So those are a couple of different reasons why the poor amphibians are vanishing. And you know I love my amphibians with the oxalot in the back room. All right, importance of amphibians. They are very sensitive to biological indicators, which makes them very valuable to us. The adult amphibians do play a vital role in the ecosystem and communities, and they are very genetic. They have a lot of genetic storehouses for pharmaceutical products waiting to be discovered. For instance, other scientific things. For instance, my oxalots have the ability to regenerate limbs, which means if their arm gets chopped off, voila, it pops back up in another 2 months or so. So that is kind of a unique thing. If we can figure out the genetics behind that, maybe one day we can apply that to humans, which could help with amputees and people who may be soldiers hurt in war and all sorts of different things. So they are very valuable for future research. Here's a couple of pictures of the frog life cycle. All right, keystone species, going back all the way to the American alligator, a keystone species and a foundation species. We're going to look at the difference between those two and also what they have in common. A keystone species are usually your top predator. They keep everything else in check. They allow for, you know, everything to kind of keep going the way it's going and keep everything with a nice flow within the ecosystem. A good example is pollinators. I talked about this before. If 1 out of every 3 bites that we eat comes from pollinators. So without those pollinators, we wouldn't survive very well, and our population would probably drop dramatically. Another thing is a foundation species. A foundation species, and to be honest, the American alligator is both of these. A foundation species is where they actually create and enhance their habitats, which benefit others. For instance, elephants, they dig holes with their feet to find water. Well, eventually that water flows up from the bottom, and as well as the holes they dig congregate water when the big monsoon season happens. So that allows other organisms to drink and have water. Beavers, another reason, they dam up streams, which causes a still body of water, which some organisms need a still body of water more than they need a flowing body of water. So that allows that habitat to change and really enhances that habitat for other species. So that's why they're a good foundation species. Uh-oh. And our last one is our case study, why should we protect sharks? Sharks do a lot of different things. They eat dead and dying fish in the ocean. They're great cleaner-uppers. They have very strong immune systems as well. Their wounds do not get infected, and they actually almost never get cancer. So, loss of biodiversity. A lot of people kill sharks when they catch them in nets, when they're fishing, when they're going fishing, when they're doing mass fishing for commercial fishing, they kill the sharks or throw them over, they chop them up, whatever. That's kind of bad. I mean, if we don't really know what allows them not to never get cancer, we really need to investigate that more, since that is the number one killer of human beings in our world. So those are a couple of different things we should, really investigate on sharks, and why we should protect those, because they could be very, very valuable to us later in our existence. So hope you guys enjoyed chapter 4. Hopefully you'll study up for the quiz for tomorrow, but have a great rest of your night. See you later.